Now let's say we are given this expression y is equal to fx is equal to x square minus 4x plus 10. Simple x square minus 4x plus 10. And the task is exactly the same. We have to find the vertex. We have to find the minimum value, minimum value or maximum value of the expression. And we have to find the axis of symmetry. So now we know that a quadratic expression ultimately turns out to be a parabola. When drawn, it is actually a parabola. So in order to draw this parabola, I have to actually build this story from the basic function, that is y is equal to x square. So in order to actually create that step over here, I first need to actually find the vertex, and for that I have to actually complete the square over here. Now this is the task. So I have to do square completion, and we already know that step. We know that for that the basic formula which always helps us is a plus b whole square, which is a square plus 2ab plus b square, and a minus b whole square, which is a square minus 2ab plus b square. This is my only savior. I don't need to do anything else besides these two formulas. So in this case, we have already done this step. We already know the process. So this is the task which is to be dealt. So in this case, now this is a square, x square. So I have to break this term in the format of 2ab. Always in any such question, this is the task. So I have to create this 2 outside x. So what is left after actually this, taking this 2 out and just writing x over here, I'm left with a 2 now. So now this is x square minus 2x, in a way this is y. So I just need a y square here in order to complete this square. So in order to complete this square, I've added this y square, which is in a way 4, and because I've added it, so I have to subtract it as well, so that the term remains the same. So this would give me x square minus 2xy plus y square, which is straightforward x minus y whole square. Now I'm left with this minus 2 square, which is minus 4, and plus 10, which was already there. So 10 minus 4 gives me 6. This is the first task of completing the square. The moment we have done the square completion part, after that just everything falls into place, because after that we know the understanding. So now x minus 2 whole square plus 6. We know that when we are going to draw this, if I simply draw this term x minus 2 whole square plus 6, we know that this is a parabola which is created by simply taking x square, shifting it to the right by a distance 2, because this is x minus 2 whole square, and then moving it upwards by a distance 6. So are we able to see that this is the parabola that is required? This point is 2, 0 and this point is 2, 6. This is the height. Now this point is actually 0, 6. This is the height 6. So now we can clearly list that the vertex of this parabola is this point 2, 6. So now we can mention the vertex. I'm just listing at this as V. So this vertex is now at the point 2, 6, and this is the axis of symmetry, which is what? This is a vertical line x minus 2 equal to 0. This is the axis of symmetry. The domain is the same. What is the domain of this function? It is x belongs to all real. And what is the range? Range of this function is y greater than equal to 6. This is my complete answer. This is my complete answer to this question. So now we also know that. So this is the complete answer to this question. So now we also know that the examples which we have dealt right now, both the examples, we can see that I have taken cases where the parabola was opening upwards, because it has all happened through the basic logic of, let's say, y is equal to x square. I've simply moved it left or right, and both the examples were exactly based upon that sense only. But let's say we are given this term y is equal to minus x square. So we know that y is equal to minus x square. Through the logic of transformation, we know how to create y is equal to minus x square as well. It is nothing special. Simply y is equal to x square is this, y is equal to minus x square is this graph. Simply just remember that we have learned how to create minus fx while doing transformations. If the graph of fx is upwards, the graph of minus fx becomes downwards. So it is just a reflection of the graph of y is equal to fx in the x-axis. So therefore, I have just taken, in order to draw this graph, I have simply taken the mirror image of y is equal to x square in the x-axis. This is the graph of y is equal to minus x square. So now we can see that this graph is opening downwards. This graph is opening downwards. So if someone asks me to draw this term, minus x minus 3 whole square. So now I know the process. Minus x square graph is known to me. Minus x square graph, you don't have to create this graph, this graph every time. You now know this graph. This is y is equal to minus x square. So minus x minus 3 whole square is to be created by simply taking the graph of minus x square and shifting it to the right by distance 3. So this would be the graph of minus of x minus 3 whole square. Simply I have taken this graph, y is equal to minus x square, and shifted it to the right by distance 3. That's it. This is the graph of y is equal to minus of x minus 3 whole square. And now if someone asks me the domain, range, minimum value, vertex of, let's say, this function, so I can list this as well. In this case, the vertex is the point 3, 0. The vertex is the point 3, 0. And the vertex is the point 3, 0. And the axis of symmetry is this line, which is x minus 3 equal to 0. Domain is again x belonging to all real. For quadratic functions, it would be always same. For any value of x, we are able to obtain a value, corresponding value of y. But in this case, the range would be different. Now the range would be, in this case, can we see that the possible values of y, the values of y which we are getting, are actually any value less than equal to 0. Can we see that for any value of x, we are not getting a value of y which is greater than 0. All the values of y, these are the values of y. They are all negative in this case. So my range would be y less than equal to 0. And we are able to understand this range even by just looking at this function. We can see that what are the possible values of y. Look, just for any value of x, the value of y is negative. For this value of x, the value of y is negative. For this value of x, the value of y is negative, and so on. So can we see that for this function, the range is y less than equal to 0. This is the sense. This is the basic sense. And this parabola is opening downwards. So this parabola is having a maximum value now at this point, 3, 0. So this parabola when drawn, this quadratic function when drawn, results in a parabola. And this parabola is having a maximum value at the point 3, 0. This is the sense. So a parabola would be having a maximum value or minimum value depending upon whether it is opening upwards or downwards. If it is opening upwards, it would be having a minimum value, and if it is opening downward, it would be having a maximum value. So that is the sense.